So in this video I want to show you how to prove the quadratic formula using completing the square method. So recall that the quadratic formula says that ax squared plus bx plus c equals 0. This is the standard form of quadratic equation, and we have to say a cannot be 0, because if we let a to be 0, then we're gonna have 0 times x squared, which is gonna be 0, and we are just gonna be left with bx plus c, which is a linear function. It's not quadratic function anymore. So in order to make a quadratic function, we have to say a cannot be 0. Alright, so what I want to do is I want to divide everything by a in this one. So I'm going to divide all this quadratic standard form by a, and this, if you divide ax squared by a, you're just gonna get ax squared, because this a gonna cancel each other, and then bx divided by a is just gonna be b over ax, and c divided by a is just gonna be c over a, and then 0 divided by a is just gonna be 0. So we got up to here so far. Now what I wanna do is I wanna look at this middle term, which is the coefficient of x. So we see b over a. We want to divide this by 2 and then square this one. Whatever we're gonna get, we're gonna add to the both side of the equation. So b square is just gonna be b square divided by 2a square is gonna be 4a square. So I'm gonna add this one over here. So it's gonna be x squared plus b over ax plus b square minus 4a square. That's gonna be equal to, bring this one over here, which is gonna be negative c over a. And because I add this one on left hand side, I have to add it here too, so it's gonna be b square over 4a square. Alright, so the next step, I can rewrite this left hand side as the square of x plus b over 2a square. So if you multiply this, you're gonna get this exact same thing, because we made this a complete square, so we can just easily raise this to the second power. And if you don't believe me, you can just multiply this 2 and you're gonna get same thing as it is here. So that's gonna be equal to b square minus 4a square. I'm just switching this, and so that is negative c over a. And because I have 4a square and a, and I want to make this one same, what I have to do is I have to multiply this both sides by 4a, and this one too by 4a. So that's gonna give me b square minus 4 times 4a times c is gonna be 4ac, and we're gonna have same denominator on the bottom. So I'm just gonna erase this and rewrite it. So we have b square minus 4ac, and all of that over 4a square. So now from here, if you take the square root of both sides, and because you just took the square root, you have to put plus or minus on the beginning. So this is gonna be x plus b over 2a is gonna be equal to plus or minus, and we can further break this down as using the property of radical. So this is like division, so you can divide this separately, in this case I am just dividing the top one, and then do same thing to the bottom one, like so. So you're gonna get x plus b over 2a is gonna be equal to negative. You cannot take the square root of the top one because it's not a number for AC. However, you can take the square root of bottom one, which is in this case is gonna be 2a. Let's put plus or minus. So we got x is gonna be equal to, take this over to this side, that's gonna be negative b over 2a plus or minus square root of v square minus 4ac, all of this over 2a. And because we have this same denominator, we can rewrite this as x is gonna be equal to negative b plus or minus square root of v square minus 4ac, all of that over 2a. And that is your proof to the quadratic formula. So thanks for watching.